Hey students, welcome back. This video is going to be on Charles Law or 7.4, but here's our bell ringer. Check it out first. Hit pause, see you down below. Okay, welcome to Charles Law. This is 7.4, this is Charles Law, page 16, or something close to that, right? So, the previous video was about Boyle's Law, where we talked about the relationship between pressure and volume. Today, Charles Law talks about the relationship between temperature and volume. Whoa. All right, temp and volume. So when we demonstrated this in class, we took the balloon and we put it in cold water, and what should have happened? The the volume should have went down. So as we lower the temperature, the volume should go down, and also vice versa, right? If temp goes up, the volume goes up, right? So our formula here, officially our formula, because this is a direct, right? A direct relationship. Officially our formula should be V1 over T1 equals V2 over T2. Well, I don't like working with fractions. Anybody else? No hands. Okay. All right. So here we go. I'm going to solve for this. V1 T2 equals V2 T1, right? That gets it out of the fraction form. And so I don't have to spend so much time trying to figure out what to do if I'm trying to solve for a temperature. All right. But the big key here, we have a big one. Boop. All our temperatures have to be in Kelvin. And the reason for that is because Kelvin has no negatives. So when we have no negatives, we can't have negative volumes or later negative pressures. We don't want that. All right. So here we go. Let's look at our first example. We're just kind of going to plug it in and jump right into it. So here we go. Let's start underlining. What do we know? 25 degrees C. Ooh, that's a temperature. Probably T1. All right, we have a volume of 275. There's V1. The temperature then goes up to 130. That's T2. And the pressure is held constant. What is our new volume? So we're looking for volume. So here's my suggestion. Over here on the side, as we're writing stuff down, all right, go ahead. So we've got V1, right? Don't know what happened there. All right, we've got V1, we know is 275. All right, T1 is 25 degrees C. So let's go ahead and put that into Kelvin by adding 273.15 to it. So that way our work is already done. That gives us 298.15. V2 is our question mark. T2, we raise that to 130. So we're going to say 130 plus 273.15. All right. And we get 403.15. 403.15. That's our Kelvin. So we've already put it in Kelvin, which is what we really needed to do here. So let's move on to our next step. All right, remember we're going to use this formula right here. V1 T2 is equal to V2 T1. Notice how the T's are switched or on different sides, okay? So let's start plugging it in. We've got 275 times T2, the second temperature, 403.15 is equal to V2, that's what we're looking for, times 298.15. All right, now we're ready to solve for V2. How do we isolate V2? Well, if we divide 298.15 on each side, divide by 298.15, boop, boop, that'll give us V2. So if we plug this in, V2 is equal to 275 times 403.15 divided by 298.15. And that'll be our answer. So let's plug this in. 275 times 403.15 equals divided by 298.15. 298.15. All right, and our answer should be 3. Beep, let's blow that up. 371.85. 371.85, and our label is milliliters. Does that make sense? Let's go back and check. So our temperature went up, so our volume should also go up. Did it go up? It did. Awesome, almost by 100 points. Okie dokie, let's try one more. See where we get from there. Now this one's going to be a little bit different because we're solving for a temperature, but I think it's going to be okay. So 65 degrees C, hey, there's T1, 4.22 liters. V1, all right? What temperature in Celsius? So we're going to have to do a little work. We're looking for T2, but we're going to have to do work. There's V2. All right, let's go ahead and solve this. So let's put this over here. We've got V1 is equal to 4.22 liters. T1 is equal to 65 degrees C. Let's go ahead and add 273.15 to that, so it's already in Kelvin and we don't have to worry about it. All right, 338.15. V2 is a 3.87 liters, and T2 is our question mark, but it wants it in degrees C, so we're going to have to do some work to kind of come back to that. So remember our formula, V1 T2 is equal to V2 T1. All right, so let's start plugging it in. 4.22 is my volume. T2 is my question mark, so I'm going to leave that T2 is equal to V2. 3.87 times T1, which is 338.15. All right, so how do we get T2 by itself? Well, you say, Griffith, we're going to divide by 4.22. So we're going to divide by 4.22 on each side to get it to cancel out. And now T2 will be by itself. 3.87 times 338.15. And then divide by 4.22. So notice how our volume is going up, so our temperature should also go up. So 338.15 times 3.87. Those numbers are pretty similar, divided by 4.22. So our temperature here is going to be T2 in Kelvin, it's 310.10, but that is Kelvin. So we need to get it back to Celsius. Change colors here. K is equal to degrees C plus 273.15. So this is going to go in right there. 310.10 is equal to degrees C plus 273. So if we subtract each side by 273, that'll give us our degrees C. So minus 273.15, and we should get degrees C 36.95. 36.95 degrees C, and there we have our answer. Awesome. See you next time.